And welcome to Desk Ladyada.
Hey everybody, and welcome to my desk. It's me, Ladyada. With me, Mr. Ladyada on camera control,
Hello.
behind the scenes. Any new updates? We're back to our shows.
Everything's back. We're doing a bunch of new camera setups and everything, so you'll notice like lighting's a little bit better, sound will be different. So we're just experimenting with stuff because we're condensing all of our shows into like maybe one multimedia station. So we'll see.
Multiple shows, but like instead of, we usually have like different cameras and locations. We're trying to unify it a little bit.
Yeah, so we're not going to the Adafruit factory. Well, sorry, we're not staying at the Adafruit factory at night because we have a baby now. So instead of staying there all the way till 9 o'clock at night, we go home and we do our shows live and
from my desk.
From your desk, and we also have a kiddo. Kiddo is super nice and quiet and chill, and enjoys listening to her mom talk about electronics. So with that being said, what are you working on this week?
So this week, because we actually, a lot of people got back from holiday and we got back from our break, and so we started the show. So not as much engineering happened this week. A lot of it was mostly just kind of catching up with everybody. What's going on the last 6 weeks or so, starting, getting people started on projects for the new year. Some really cool projects coming out already. I've, dished out some really fun engineering projects to people. We're going to take on some interesting new quests. Plus there's a lot more new chips coming out and chips that are coming back into stock. As I've mentioned over the last, couple months, the chip shortage, while it's not over, has been a lot better. In fact, it's sort of turning into like a chip surplus, which you might have seen, like Samsung said, wait, we have too many chips now. Which is why we didn't start a chip fab. Everyone's like, Adafruit should buy a chip fabrication factory. It's like, no, that takes like 10 years and we're pretty busy. And also now there's a chip surplus. So what I've been doing recently is first off, we're trying to get a lot of stuff back into stock. We're going to restart some old designs. There's a lot of designs where they were kind of ready to go, or they were about to be revised in like 2020, and then with various shortages and inabilities to get stuff done, like some stuff did get revised, but there's some things that were, if it had like 3 revisions involved, I kind of emotionally gave up on it and said, I'll just check it out when I can get everything. So one of them is this TFT feather wing. Let's go to the overhead. So 2 weeks ago, I think I talked about the let's see, hold on. Whoops. Let me auto focus and then focus lock. Okay. I talked about how I'm trying to change some of my hand solder TFT and OLED displays into plug-in version. So check out those previous shows, because the 0.96 and 1.14 inch TFTs, traditionally they're hand soldered. So this is what it looks like underneath. Hold on. So, these are hand soldered and then taped using, traditionally you would use a hot bar machine. We solder it by hand. So one, the hand soldering does take a lot of labor, and if we're making enough of it, it's better for me to make a double-sided design with a TFT plug-in. And second, this TFT actually got discontinued, and then the TFT shortage showed up, and the TFT prices like quadrupled or tripled. And I was like, I'm just going to wait. And then I was using a Seesaw SAMD09, and then the prices on those went up a lot. And then I was like, should I change it to an AT Tiny? And then basically like 3 things went kind of amiss with this design, and I just sort of said, like, I'm giving up on this for now. Let's revisit this later and, maybe update it when I can get all of the pieces, or maybe I'll redo all the pieces. So let's go to the computer and I'll show what I'm going to change. So, this was, so one of, before, like during kind of COVID time, what I was trying to do was like, I'll update this 0.96 TFT, because when I designed this feather, I could only get the 0.96 160 by 80, but then the really ultra high dense 1.14 inch TFT came out, which is 240 by 135, which is like really even, which is much better, much higher density. And so I started redesigning this to use the 1.14 and then use, instead of the SAMD, I'd still use the SAMD09. But then, like I said, I couldn't, like the SAMD09, I could get it, but the price was really high. And I was like, I'm like not so into it. Especially since the Seesaw chip, the only thing it was really doing was controlling the backlight TFT. and doing button reading, and then reset. It was one GPIO output, like 8 GPIO input, and 1 PWM output for the backlight. And at the time, there's like no chip that did all three things. There's no I/O controller that I could use. I did input, output, and PWM. But then recently, one of the breakout boards that we added was the AW9523. And this GPIO expander is actually kind of neat because it actually does both input and output, and can do constant current PWM output for backlight control. So it's actually kind of perfect for this use. And I want to, and also the price of it is really good. It's basically cheaper than the SAMD09. I don't have to program it, so there's no risk of like the chip getting erased or like misflashed, or like the extra step where I have to SWD program it. So I want to update this design to use that instead of what I've got right now, which is that SAMD09 doing the breakout board control. So so I'll show you what I have. So it's basically everything's changing. And then another thing that happened is I changed the large buttons to these small buttons. But I think what's going to happen is, because I'm changing this to be, so let me save this as, actually I already have a rev. I'll just save this here. So the first thing is, let me turn off the, let me rip up the whole thing and get rid of the traces, because none of these are going to stay. So the first thing is I'm changing this hand solder TFT to be a plug-in. So let's do that first. So this TFT is, let me update all the libraries, because I have a new package for the plug-in version. Hold on, EagleCAD's thinking. Okay, that's fine. So if I add, somehow I have like a 16-core processor, and EagleCAD still is just like constantly thinking. Okay. For the TFTs, so I've got generic TFT hand solder. Actually, let me just look at Adafruit display, which is my library with all my displays, and it was called, generic SPI no LED A. So it's actually no LED K. So the one thing, I got both the 0.96 and the 1.14. Sorry, no LED. Yes, no LED cathode. So the only thing that's a little different about this is that, this is, I made it kind of like a compatible footprint, but you'll notice there's no cathode for the LED. The LED, for these plugins, to save pins, they don't have both the LED cathode and the anode exposed. The cathode actually connects to ground, which is actually a good idea, because the power supply for the LEDs might be different than the power supplies for the chip, but it just means I have to change the logic for the backlight to be inverted. Okay, so if I plug this in over here, and then I'm going to align this to be the same, so it'll be like here, that, and then I'll get rid of the hand solder version, and then the LED anode, I'll click to the backlight. I can check the, I may or may not, like if it's, I'm changing so much firmware and software anyways, maybe it's not a big deal. I'll just have the example code so it's logically inverted. Okay, so next up, I'm going to get rid of this SAMD09. Goodbye. And instead, I'm going to import the breakout board for the GPIO. I think, where do I put it under? It's under multiplexers. I word C? No. It's under, I can't remember where, it's under ADCs, audio, clock gen, coprocessors. Level shifters? No. Not under PWM. Under LED drivers? Oh yeah, under LED drivers. Okay, so I added this sheet, which just kind of brings in all the pins and they're all labeled nicely. But I'll still delete all the headers because I don't need the headers. And I'll delete, you know what, maybe I'll keep the stemma QT port. I'll delete the mounting holes and the fiducials. So you see it's kind of like hanging out down here. And I think I'll keep one stemma QT port because that might be handy. People can like, oh, if it's double-sided anyways, like I'll just, I'll have it on the bottom. And then I'll select this and drag it over here. And I can delete this sheet. Okay, so then I'll clean this up and I will delete. And I was like, you can't delete everything. So now I've got this, this chip is going to be the expander instead of the seesaw. And I'm going to, this was at a quirky angle. Change that back to normal. And I'm going to put this on the back because now it's double-sided. I might as well put it on the back. I can put this on the back and this on the back. And then I'm actually going to change this package back to be 6 millimeters. Because I actually kind of I like that size. And then this can kind of shift over a little bit. And then this like barely fits. Let's see if I can change. This is change package. I'm gonna use smaller. It's like a tiny bit smaller. So yeah, now I'm back to kind of how it was before. And yeah, it's a double-sided design now, but like I said, I'm kind of stuck with that because I want to have this plug-in TFT, but the good news is that there's no hand soldering. And there's not an unpopular feather wing, and one of the things that like takes time is hand soldering those TFTs. So I'll make it double-sided, have that plug it on the back. So the only thing I have to do is add a cutout like here. So I'm going to add that now before I forget. And I will do that with the lines tool. Oops. And then you just make a cutout by using a dimensional rectangle. And then kind of move it out of the way. And I have a slot. And this is great because then the FPC will come out and we'll have plenty of space to tape it down. And it will plug in onto the back here. And then I just have to like kind of, route everything and arrange it. But I have lots of space. I'll get rid of all this silk screen. The silk screen obviously is not even correct anymore. So let's get this out of the way. And
is it hard to know exactly where to put the cutout?
No, because I actually played with this before, and so I know you can see that there's this this outline here. Let me move this text over here. This will probably move over here, and then this will kind of scooch, and then this I'll rotate, and so you can see where the FPC comes out, this little like a jiggly line. So I just kind of make it like a millimeter more, and that way I can see, like when I document the footprint on the back, I like to document where the flex connector goes. That way I know like I can put components where it won't overlap, and also like it told me like, okay, I just need to have this slot here. But then I'm pretty much good to go. So I'll finish routing this and I'll send out prototype PCBs, but I actually kind of like moving the Seesaw chip to the AW 9523 is kind of like, it was like all three pieces came together. It's like, oh, I can get the TFT for the FPC plugin. I could get the AW 9523. It's now available and it's low cost. And we got enough other boards revised that I was ready to like bring this one back to life. So there's like 6 or 7 different designs that kind of went through this. Like things where 3 or 4 parts went out of stock and I was like, I need a break, but we'll bring this back. So for the great search, I thought I'd show...
Let's do 2 quick questions.
Oh, yeah, sure.
Ready?
Yeah.
Have you ever done Eagle tutorials? And the next one is, would a ZIF socket for the TFT display make it expensive?
There's no such thing as a ZIF socket for an FPC. So there's flip top, but this isn't a flip. This isn't a bottom contact. It's a top contact. So you have to use a little slide out. We have Eagle CAD tutorials on the learning system. Some very good ones.
How will the new chip change the code for using it?
It's going to be new code, but like I said, the TFT is changing also. So there's like so many things changing that if you're going to make one change, make all the changes you want, and this will make it easier to manufacture and less expensive.
And I guess this is the follow-up. Even just in the library backend?
I mean, that's not how we don't have a library for this display like we have example code.
Okay. All right, cool.
But it's like a popular display type, and the AW9523, we have library code too, so it's not so bad.
All right, and do you want to get on to the great search?
Yeah, let's go to the great search and we'll show on the overhead.
Kick it.
Yeah.
Where in the world is that part I need? The great search with Digi-Key.
The Great Search brought to you by Digi-Key and Adafruit. Thanks, Digi-Key. This is the time of the week where Ladyada uses her power of engineering to help you. Yes, you find the chips, parts, and more that you need. Ladyada, what are you looking for this week?
I'm glad you asked. This week I've been doing a redesign of a TFT Featherwing, and the TFT Featherwing has an interesting navigation switch on it, and I realized this is a pretty cool, weird part that I would like to show because the original manufacturer stopped making it, but there's an alternative that's basically pin compatible. So let's go to the overhead and I'll show it off. Okay, so one thing that's if you're adding buttons in a user interface to a project, it's very common to have like a navigation thing, like up, down, left, right, and then usually a select, so you can go through a menu or you can change specifications. This is a little joystick as well. That's another option, and this one doesn't have a select. It's only a 2-axis joystick. But usually, you'll have this, and then maybe you'll have a select button next to it. We don't also have a joystick we recently put into the shop that is through hole, but does have a select on it. Hold on, let me get some good focus here. This nav switch is one that I like quite a bit. So these nav switches, they're a little bit more compact than a joystick, and they're not. This is true analog joystick, so you need 2 ADCs, X and Y, and you can measure, in the center it's, ADC, VDD divided by 2, and then as you go left and right, it goes from 0 to VDD. These navigation switches, they tilt, you can kind of see that they tilt left, right, up, and down, and they do have a select, and they're kind of clicky because they really are 5 mechanical switches. So I call them 5-way navigation switches, although some would say it's 2 axes plus select, different ways of talking about it. But I like them because they're not that much bigger than like 2 tactile switches, and they're definitely smaller than 4 tactile switches. And they're very logical. You're like, oh, it's a little joystick. Like, I understand what you want me to do. You want me to move up, down, left, right. And so in case people wanted to add these to their products, I thought I'd show this part and some other parts on Digi-Key. There's a couple navigation switches. Okay, so this is the just show this was the design, and this is the footprint. So it's nice is that it has 5 switches, and then they have 1 common and 5 pin pin connections. So that it looks like this, one comment, up, down, left, right, and then select in. So you just need 4 GPIO pins, and you connect the comment to either ground or power, whichever one you want, and you just need pull-ups. So, and then here's, just in case you want to see a nice big picture. Oh, here it is. So this is the what it looks like in big letters. So these are called navigation switches, and so watch out because there's also thumbsticks, right? And that's kind of similar, and sometimes they are grouped together. But thumbsticks tend to be just small joysticks that are analog. So you see these APEM switches. I mean, these are very fancy. We have this one. Like I said, this is XY, but not select in. Some of these have select, some of them don't. But thumb switches tend to be analog to axis. So instead, what we want is I'll go to the entire category. Navigation switches. Now, what I'll see is there's some really good stuff here, and like the thing about navigation switches is that there's a wide range of the navigation joysticks. They're from like very tiny ones. Like this one is very small. This is maybe 8 millimeters by 8 millimeters. These are very tiny, and they're pick and place surface mount to like large joysticks from like Gray Hill with like a gigantic IDC connector. So they're all slightly different. Like here's this big analog joystick, and you can even see the 2 pots on the side. But we want and then this is kind of a nice, it's like a vehicle, like this is from a car navigation. Another one that's very popular is this one. This is like, the Xbox style controller joystick. A lot of these you'll notice they originally were made and used in console games or phones or something, and then the part became genericized enough that you can then get it outside of that use case. So like, this is absolutely like a clone of like the Xbox controller joystick, nubbin from the original like Xbox 360. But you can get them now, and they are 2 pots and a selector switch, and they're very inexpensive. So these are larger, they're not surface mount, but they're also good options. So let's look at the active navigation switches. And there's like different directionals. There's ones that are like Hall effect. We want mechanical switch. Yeah, just mechanical. I think it will be under that. And then thumbstick again is usually analog. And joystick is usually something you grab with your hand and you move back and forth. So you want navigation switch. Oh, I'll show you the one-axis ones. There's some fun ones. Actually, never mind. Sorry, let's go. Let's stay on target. I'll show you the navigation switch later. Okay, so here's all the options for navigation switches. So again, there's like a mix match. There's like this ADA assistive device, but let's search by pricing so you can see all the different cost versions. So unfortunately, there's a lot that don't have photos, so you'll have to check the data sheet. eSwitch in particular makes a lot of these. These are very slim style ones, so they're not too dissimilar than the nav switch I showed you, but it's like very compact, and you would have your own. It's hard for a finger to do it. You'd want to have a mechanical add-on. This one I've seen in a couple projects. They're fairly inexpensive, and they're surface mountable. And then this is the one that, like I said, this is the through-hole version of the navigation switch. So you can see that you can kind of sort of plug this into a breadboard. It's not quite breadboard friendly, but you'd have to solder it in. And then if you go down, you'll see there's, again, a kind of a slim surface mount version. And this is the one that I use. So this is, you can see the 360. 1 second. So you can see this one has mounting nubs on it, which is actually kind of nice because it'll keep it from shearing off. And there's little like clip-in bits that if you want, again, make it mechanically stable so when people are pressing up and down, it doesn't shear off of the PCB. But it basically just has 6 pads. You can pick and place it. It comes on a very thick tape, but as long as the pick and place nozzle can get onto that actuator, you're good to go. And one thing that I thought was kind of neat is this is available in the EagleCAD KiCad library, or the Digi-Key KiCad library, which I didn't know that they had. So do check it out. They also have a bunch of tutorials. So if you want Sean to teach you KiCad or KiCad, check out the tutorials. There's also the CAD models, the STP files, and you can sometimes get the if you're not using KiCad, you're using Altium, Eagle, whatever. You can get the footprint from Snap EDA or Ultra Librarian, which actually I've been using a lot lately. I've been getting footprints for parts, even if I sometimes redraw the schematic symbol because I like to have the parts grouped in a certain way. I'll reuse the footprint because they did the math of getting the pads in the right location. So check that out. And another thing is for a lot of these nav switches, you'll want to have a cap on top. For the navigation switch that I use, there's a little rubber cap that we actually sell. It actually did appear down here. Let me see. Hold on. There you go. This black nubbin joystick, which Digi-Key stocks on our behalf, fits on top and even has a little joystick symbol. It's not sold by eSwitch. It's actually a third party, but it fits very nicely on top of these 5-way nav switches and kind of gives it a nice rubbery feel. And you can see here what it looks like. It does. The only thing that I didn't realize is it overlapped the reset button, and so on the redesign, I'm moving the reset button because when this was designed, I didn't have that rubber nubbin piece. But then I added it later and then realized it was a little in the way. So that's the only thing to watch out for is it does overlap your bike components. However, like I said, I really like this nav switch. Strongly recommend it. It's really great. It's very compact and takes up a lot less space than 5 tactile switches, and never had anyone say, oh, it was confusing to use or difficult to use. I think they're kind of a joy for adding an interface to your project.
That's a great search.
Where in the world is that part I need? The great search with Digi-Key.
All right, we're going to do some questions. You ready?
Yes.
Okay, here is some questions. First up, could you add maybe the AW9523S for finding that chip? AW9523S.
I don't know about the S type.
Okay.
Sorry.
Next
but
up.
the 9523 is what I just used the QFN version.
Do you have predictions for the end of the silicon shortage, mid-year, end of year, never?
I think by the end of this year, we're going to be pretty much out of it. But I think I'm still getting microchip at SAMD dates of 2024. I don't know if those are realistic or not. Everybody else has kind of wrapped it up. Although I'll say that there's a lot of things that went end of line in the meantime.
All right. Does the RP2040 Scorpio have Bluetooth or Wi-Fi? If not, how could you do it, or would it be better to not do it?
You can add Wi-Fi with a Airlift Feather Wing, and it won't. That's fine because the Scorpio output doesn't conflict with any of the feather pins, so you can totally add Wi-Fi that way. Would
you ever make a standalone Scorpio that has that built in?
I would probably look at just porting the Scorpio code to the ESP32 and having that do it. There's trade-offs though because the RP2040 is really great. at driving NeoPixels.
Okay. Any word on last March's F1C 100s or even a F1C 200s board? I have a trove of documents, info, etc. I've gathered over the last year.
Oh, send them over to PT at Adafruit. We're actually going to look into doing that board again. It was one of the chips that, even if that chip wasn't unavailable, all the accessory chips that go with it, like the power supply and memory chips, were unavailable, and so we had to put pause on it. Plus, that chip was quite, I got a couple samples, and then it was tough to get a reel of them. But we'll probably be doing it this year.
And in chat, it was noted that Texas Instruments TI just did end of line notices to a ton of their products.
I know they did, and I think they're going to do it for the Power Boost chips. So I have to redesign the Power Boosts, but they keep saying they're going to ship us chips. But
that's one way to no chips, no problem. That's one way to solve
it's a little
the
bit,
shortage.
yeah. It's like, hey, it's not out of stock because it doesn't exist.
We never said we had these.
Yeah, I know.
They're just going to erase it from their website. So,
Yeah.
Okay. All right. That is. Oh, was the Scorpio cowbell mentioned?
There's no plans of one right now, but you can just use a Pico and just wire it up as is.
All right. That's our show for tonight. Special thanks to all the community, all the Adafruit team members, everybody's out there, and Baby, who just loves listening to electronic stuff. Hanging
Baby
out.
Ada is just being super chill.
Yeah, she loves listening to Mom do electronics. Okay.
Okay.
That's it, everyone. We'll be doing our shows during the week. Thank you so much
Thank
for
you,
supporting
everybody.
a woman-owned company here in New York City. Your orders keep us going and more. Thanks so much. We appreciate it. We'll see everybody next week.